To estimate beta, we are going to first come up with the deterministic estimate of beta, and then we will use the probability distribution to simulate those values. Now, one way of figuring out beta is to run a regression between the Facebook's rate of return and then against that as y against the NASDAQ average, so it will be like the average of every. So we are comparing one company against the average. So um, that regression will give us an estimate of what beta is. So the regression slope coefficient will be used as the average value for beta, and then the standard error associated with that beta can be used as a standard deviation. So we'll use the slope as the mean and the standard error as the standard deviation in a normal distribution, and that will give us what the beta will be. Okay. So for that we need historical data, which is what we have here in FB, which is Facebook. Okay. So we have data going from May 18th to January 25th, 2012 to 2019. Okay. And we have the NASDAQ price as average as well. So now we need to look at the rate of return, daily rate of return, for Facebook, and then for the NASDAQ average. Okay, and then we will do the regression. So here we're going to assume what is called log return. So the regular return would be like what? You'll go the change, right, divided by the starting point. So that will give us the rate. Okay, but a more common way of doing this is to find the logarithm, natural logarithm of B3 divided by B2, and this gives us what is called log return or continuous compounding. Instead of daily compounding, it gives continuous compounding. So this is what people normally use. So here FB return, and then we'll say NASDAQ return, right? So you copy that over there, so that will give us the NASDAQ return for going from one day to the next trading day. So now we copy that. Okay, let's go down and up like that. Okay, so now we copy everything. So that means we have now Facebook log return and NASDAQ log return. Okay, we can now run regression, data analysis. All right, select regression. Input y, so y will be FB return, and x will be NASDAQ return. Okay, and because the first cell is the label, we have to check label, and then we want output range. Okay, let's put the output here. Okay, and click OK. Okay, now here is the coefficient. That will be our mean beta, and this is a standard error. That will be our standard deviation. So we go to model 2. Alright, so now we have beta estimates. So we'll put that in. Okay, so we have mean and standard deviation. So mean comes from here and standard deviation comes from there. Okay, let's do some formatting. Okay, now we'll use risk normal. Okay, so that's why instead of 1.14 we want to generate from this distribution. So let's erase that and risk normal, right? So mean and standard deviation. Okay, so now we have set up at risk function for beta. So now we have these three simulated from the expert opinion and beta simulated from historical data. So now before we run the simulation, we set this up as output, right? Then make sure that multiple CPU is selected as automatic. I'm going to do 10,000 simulation. Click simulate. Right, so we have now the total value. Okay, so here is 90%, middle 90%, and we have the more detailed statistics. So the 1% first percentile, and then 99th percentile. And you can have 25% and 97.5% will give you 95% of values in between. And then you have the standard deviation for amount of risk and so on. So you can study this and analyze this. Now we can also go to the tornado chart. Okay, so go to output. Now you get the tornado chart of each of the input variables. So we have 4 input variables, beta, and then the 3 expert. Beta, we did beta using regression, and these 3 we used expert opinion. And as you can see, the revenue growth is what gives you the most variability in profit. So this is the baseline, and low revenue growth can lead to as low as 410,000 million in total valuation, or it can be as high as 1,314,000 million if the growth rate is high. So between the expert opinion minimum and the maximum growth rate estimates, the valuation varies the most. And the other 3 have relatively less impact or less risk when it comes to the valuation. Okay. So the tornado chart is very useful in understanding the relationship between the input and the output that we are looking at.